Hello and welcome to your revision notes on P1.7 Energy Transfer by Heating. Your objectives for this revision session are as follows. You will need to understand that the shape and size of an object will affect how quickly energy is transferred to and from it. And secondly, that you understand that temperature difference affects how quickly energy can be transferred. For your revision, you will need to remember that the surface area of a container, the material the container is made up of, and the difference between the liquid and the container, the temperature difference that is, can affect how quickly the heat is moved from the liquid to the container or from the liquid to the surrounding air. Let's take a look now at a hot cup of tea. Every single particle inside of that cup of tea has got its own amount of heat energy. The more particles there are in the cup of tea, the more heat energy the tea will have. Heat and temperature are not the same thing. Heat energy has to do with how quickly each of those particles are vibrating, and temperature is just the average temperature of that cup of tea. The hot drink over here shown in the photo contains energy. The hot drink will cool down because energy is going to move from it to the surrounding area. The cup of tea will keep on losing heat energy to its surroundings, and it won't stop until it is the same temperature as the air around it or the same temperature as the mug that is holding it. Heat will always move from a warmer place to a cooler place. It will never go the other way around. When the temperature difference is greater between the surrounding air and the cup of tea, it is going to transfer energy quicker. It's going to transfer heat quicker. Now, what that means is on a cold day when the surroundings are really cold and the air is really crisp and cold, your hot cup of tea will lose energy faster, so it'll cool down faster, because there's a greater temperature difference between the surroundings outside and your hot cup of tea. And now just a really quick summary, and that is that you have to remember that every particle holds some amount of heat energy. Heat can be moved from one object to another. Heat travels quicker from a warm object to a cold object. And an object will continue to cool until it is the same temperature as its surroundings. Now, please remember, when I use that word object, I'm speaking about anything from a steel block to your cup of tea that we've spoken about before. The next thing we're going to look at is how the surface area of two different containers. So here you can see the surface area here is much smaller than the surface area there, but it's important to note that they are both 50 ml, so there's the same amount, the same volume of liquid in both of these. So size and shape will affect how quickly heat energy is transferred from our liquid to the surroundings. If two objects have the same volume but different shapes, like these two here, the one with the larger surface area is going to cool down more quickly. Something else that can affect how quickly heat is lost or heat is transferred is what the cup is made up out of. But before we go on to that, I just want to go over what a good conductor and a good insulator are. So a conductor is any material that allows heat to move through it easily. So we think about good conductors, we must always think about metals. Good insulators are going to be exactly the opposite. They are going to be materials that do not allow heat to move through it very quickly. And an example of this would be plastic, rubber, wood, anything along those lines. So it's very important that you understand and that you can list some of the good conductors and some good insulators. So over here we have two mugs. One is tin, which is of course a metal, and we have a plastic mug. Assume that both of them have the same volume, the same amount of liquid in that, and that they are both the same temperature. What we've got over here is the tin mug, which is a very good conductor. So it is going to allow the heat from inside of that liquid to travel through and thereby lose some of that energy. Plastic is a good insulator, so it does not allow any of the heat to escape, and therefore it keeps your drink warmer. So what we know is that the transfer of heat energy depends on what an object is in contact with. So for example, you've already learned that a good conductor will feel cool when you touch it, because heat energy is quickly conducted away from your hand towards the cooler conductor. Heat energy is transferred much more quickly along a metal spoon than a wooden one, and that is going to be because a metal is a good thermal conductor, a good conductor of heat.